In this video, we'll do some questions based on this point slope form. That means forming an equation of a straight line when we know one of its point, that means its coordinate of its point, and we also know its slope. So let's begin with one of these questions. It says, find the equation of the right bisector of the line joining these 2 points. So what we can do here is to make a line segment first joining these 2 points. Say I made a line segment. Let's say I made a line segment here and I took these points as say A and B. Let the coordinates be this. For A, I took as -3, 2, and for B, it is 7, 6. Further, we have to find the equation of another line, which is the right bisector. By right bisector, it means it is the perpendicular bisector. Right bisector stands for the perpendicular bisector. So we'll be making a perpendicular bisector of this line. That has to pass somewhere through the middle of this line. Now, what we know that this C, for example, this I took as C. C is the midpoint of AB. So we can use this section formula, that is Cxy is equal to x1 plus x2 over 2, and likewise y1 plus y2 over 2. So let's calculate the midpoint of C. As we can see here, that is -3 plus 7 over 2 will give you 4 over 2, that is 2, and its y coordinate is 6 plus 2, that is 8. 8 over 2, that is 4. We got the point C. Now what we will do now, next we will find the slope of AB. So if I find this slope, here I'm talking about the AB, using this relation, that is y2 minus y1 over x2 minus x1. What is y2 here? It is 6 minus 2, and x2 is 7 minus 2, that is plus, minus 3, that is plus 3. So 6 minus 2 is 4, and this is 10. If I reduce, we'll get 2 over 5. Now, as you must be knowing that if you know the slope of one line, the slope of the other line, let's say, for example, this be the slope of this line is m1 and this be m2, and if they are perpendicular to each other, m1 into m2 is equal to -1. In short, if two lines are perpendicular, then slope of one line is negative reciprocal of the other. So here we got the slope of AB here. That means this AB, in order to get the slope of the other line or the required line here, we have to find the negative reciprocal. That means the slope of this line, say M, will be negative reciprocal of this. That is, in this case, it's going to be M is equal to negative reciprocal of 2 over 5 is -5 over 2. Now, once we got this point, that means we have this slope now, and we also know the point through which it is passing. So we can find the equation of the line using this relation or this formula. That is y minus y naught. Y naught, as I can see, it is 4 from this point, is equal to m. What is m here? That is -5 by 2 into x minus x naught. And what is x naught here? That is 2. Now, simplifying it further, it is 2y minus 8 is equal to -5x, and plus 5 into 2 is 10. Now, simplifying it, that is writing in the standard form 5x plus 2y, transposing 10 to the left, it is -18 equal to 0. And therefore, we can say that this being the equation of the line or the required line. Now, we'll continue to do more question. Continuing with this, we are going to the question number 8 here. It says, through 3, 4, a line is drawn inclined at an angle of 45 degree with x-axis. So what we can do, we can extend this line. Let's say I'm extending this line and say this as well. And we have this angle given as 45 degree. As you can read in the question, this is this line. So there is a line that is inclined with an angle of 45 degree with x-axis. So you must be knowing that, and the angle made by a line with that of the positive direction of x-axis is called the angle of inclination. So we have an angle of inclination as 45 degree. Now, say it is drawn through a point. Let's say I took a point here. Say I can take this point only. This point, say P only. And I can write its coordinate as given as 3, 4. It meets another line, let's say, there is another line, say this one. This is another line. And the equation of this line is given. So we can write the equation over this line only, that is x minus 2y plus 8 equal to 0. We know the equation of this line. And it is meeting another line at point Q. That means this point is Q. What we have to find is the length of PQ. We have to determine this length. That means from here till here. So for that, what we can do in the step 1, we will find the equation or the point of intersection. Clearly, we will find the point of intersection of Q and we will find the distance of PQ. But in order to find the coordinate of Q, what we need to do is to first find the equation of this line. Let's say what we know here, theta, which is the angle of inclination 45 degrees. So clearly slope of this line is tan 45. So I'm talking about this line, tan 45, which is equal to 1. So we know the slope of this line. Further, we know one of its points. So we can find the equation of this line. So it's going to be using this formula y minus y naught, which is 4 in this case, is equal to m, that is 1 in this case, and x minus x naught, that is x minus 3. Further simplifying it, we are getting x minus y minus 3 minus 4 is, plus 4 is 1. So we got this equation of this line. So once we have the equation of two line, what we can do, that we will solve this equation, right? We will solve this and this equation, and its solution will give you the point of intersection of these two lines. So we can do it by elimination method. Say I'm writing the first equation, say this is the first I have taken and this is the second. So I can write this, and x minus 2y is equal to minus 8. For the second, it is x minus y is equal to minus 1. So I'll do elimination, minus plus, this get cancelled. So we have minus 2y plus y, that is minus y, and this side we have minus 8 plus 1, that is minus 7. So we got y as 7. Once we get the value of y, we can plug in y in any of these equations, say over here. So what we'll get, x as x minus 7 is equal to minus 1, implies x is equal to minus 1 plus 7, right? That is 6. We'll get this as 6. Once we get the coordinate of Q, which we have just determined as 6, 7, now we can find the distance of PQ, and we'll be applying the distance formula that we have been using since class 10th. That is x2 minus x1 whole square plus y2 minus y1 whole square. So it's 6 minus 3 whole square plus 7 minus 4 whole square. So what we are getting here is 6 minus 3 is 3, that is 3 square, and 7 minus 4 is 3 square. So this will give you 3 root 2. That should be the distance of, or the length of PQ. Continuing with this, we are on this question number 2. It says that show that these 3 points lie on a straight line. That means we have to prove collinear. Well, in this chapter, by default, we'll be using the slope of a line instead of any other properties that you have might learned in lower classes by default. Now, we have to find, first of all, we have to show that these 3 points are collinear. So let's say if I take 3 points, it can take 3 points. Let's say I took 3 points here, naming them as A, B, and C. The first here is 5, 1, and then 1 minus 1, and the third one is 11, 4. So what we need to do is to prove these 3 points as collinear. So for that, what we'll do, we'll find the slope of AB as well as BC, right? And if they are same, as you know, two lines, if their slopes are equal, can either be parallel or collinear. So let's say if I find the slope of, we will be using this formula for finding the slope as y2 minus y1 over x2 minus x1. So we are going to get the slope of AB, right? We are going to get the slope of AB in this case. So it's y2, as I can see, it's minus 1, minus 1, minus 1, minus 1, y2 minus y1. Let's say -1, and this is 1 minus 5. So we are getting -2 over -4. So it's minus gets cancelled here and we get 1 over 2. Now, similarly, if I get the slope on the other like the slope here, I'm talking about say BC, what we are getting is 4 minus -1, that is 5, and further it is 11 minus 1, that is 10. So again, we get half. So clearly, say if I say this is slope for slope AB is M1 and this is M2, what we got here, M1 is equal to M2. So when the slopes of two lines are equal, and since B lies between A and C, that's why these 3 points are collinear. Now, in the next part, what they're asking to find out is also find the equation of a line passing through these points. So we can use point slope form. We can use this relation as we know the slope, and we can take any point. There is no restriction. I can start with this. So we'll get the same answer in each case. So y minus y naught I can see it's -1. So it's y plus 1 is equal to m. We have calculated as m1 and m2 are same. I can take this as half, and x minus x naught, since I'm considering this point, so it's -1. And then by cross multiplication, we get 2y plus 2 is equal to x minus 1. Now, keeping all of them on the same side in the standard form, it will give you that is x minus 2y, and then on the right hand side, right? So it's -3 equal to 0. So this is how we got the equation of this line.